Hey everyone! Today I want to talk about a Neovim plugin that I made using Rust. First though, I want to talk about why I even use Neovim in the first place. Don't worry, I'm not going to try and convert you or anything. It's just my own rationale and experience. So, back when I worked in trading, I used to work on Red Hat Linux machines. And let me tell you, those machines were locked down. You couldn't install anything on them, and you just had to remote into them via SSH. A lot of places use PuTTY. And you just work with whatever tools are already available on the machine. Originally, I was setting up configuration files for fixed sessions in UAT, but I later started handling prod and more of the engine stuff such as routing rules for order flows. The main engines that I worked on were Java-based, and yes, many financial institutions have official development pipelines by which things get pushed to the machine rather than always editing files on the machine directly, but that deployment pipeline takes time. And I cannot tell you how many times it was absolute clutch to be able to use Vim to open a file, change a line, and get something working 5 minutes before market open. Then we just sorted out the development pipeline later and put somebody in a cage for breaking the system in the first place. So yeah, I didn't get into it as a hobbyist Vim is cool sort of thing. It was more of a job requirement. And yes, even in the era of AI, it's helpful to be able to just jump into a file with Vim. Luckily, on my own personal machines, I have a Windows machine and then I have an Arch Linux laptop. I can be a little bit more sophisticated on those and use Neovim instead of just raw Vim. And because I have that luxury of using Neovim, I like to jazz up my setup a little bit more with plugins. So my config is a keystrokes config that I repurposed from the great TJ, and I try to generally keep things minimal rather than trying to make Neovim look like VS Code. And that said, I'm not really a goddess or anything when it comes to the keybinds. I tend to hop over to my arrow keys a lot, for example, instead of using J, K, H, and L. And I wanted to sort out the silly way that I do things into more of a proper way of Vimming. So I tried a few gamified learning methods for Vim keybinds, along with reading some manuals and going to sites such as Vimprove. But I always felt like I would rather just learn by doing my own projects. So I decided to make a plugin myself. I wanted to have something pull the lesson out of my real usage after I close a file rather than annoying me while I'm working. I wanted to get a little report card that says, here's what you did inefficiently this session, and here's what to do instead. And of course, I wanted as much of it to be in Rust as possible for learning purposes. So there's two pieces to this. The first is a thin Lua shim that runs inside Neovim itself. That's Lua Mashless init Lua. Mashless is just what I decided to call this plugin for now, but if you think of a better name, feel free to let me know. The second is a Rust binary that does basically all of the actual thinking, and that lives in source. Quick note before I go further, because I'm going to keep saying API, and when I say that here, I mean a function or hook that Neovim itself exposes on purpose so that a plugin can hook into whatever's happening inside the editor, instead of some plugin author having to hack into Neovim's internals directly. Vim onKey is one of those. It's a function built into Neovim that lets a plugin register a callback and get told about every keystroke as it happens. And that's actually the reason I split this project the way I did. Vim onKey is the only API Neovim exposes that sees literally every keystroke you type. And it has no RPC binding, so the actual capturing of keys has to happen in Lua. There's no way around that I could find. But everything past that, holding the session state, running the analysis, and rendering the HTML report, opening your browser, none of that actually has to be in Lua, so I moved all of that into Rust instead of writing the whole plugin in Lua. So a quick detour to explain RPC as well, because I'm going to keep saying that. So RPC stands for Remote Procedure Call. It's just a pattern for letting two separate processes call functions on each other and pass data back and forth, even though they don't share memory and can't just call each other's functions directly. Remote here doesn't mean over the network or anything like that. It just means a different process. My Rust binary is a totally separate program from Neovim, so the only way the two of them can talk to each other is by sending messages back and forth instead of directly invoking each other's code. Neovim happens to speak a specific flavor of this called message pack RPC, where those messages get encoded in a compact binary format called message pack. So the two sides talk to each other over message pack RPC. Neovim starts the Rust binary as a job with RPC equal to true, and from that point on, it's just notifications and requests going back and forth over standard in and standard out. A notification is fire and forget. A request is the kind that expects something sent back. So let's look at main RS. Right at the top, there's a dot comment that's basically the entire protocol between Lua and Rust written out in one place. On the notification side, you've got setup, key, cursor, and buff. Those are fire and forget. Lua just tells Rust, this happened, and moves on. On the request side, there's report and open latest, which actually expects something back. After that come the imports and the app state struct. There's mod analyzer, mod recorder, mod report right up top. App state itself just holds the config. And a session config is the tunables that get sent over from Lua's setup function. And the session is the state that accumulates over the current Neovim run. Then Neovim handler wraps that app state into an arc mutex because notifications can come in concurrently over RPC, and I need shared state that's actually safe to lock. Good spot to mention that this whole thing is async running on Tokyo. Then there are two tiny helpers, as string and as I64. Values coming in over message pack are loosely typed off the wire, so these two functions just do defensive coercion, making sure a stray U64 where I expected an I64 doesn't panic the plugin in the middle of someone's editing session. Then we hit open in browser, which is honestly one of the more gnarly parts of this whole program. Neovim runs Mashless as a child job, and the moment you hit :Q to quit, and I reply to that report request, Neovim tears down the entire job's process group. So if my browser opener process is still sitting in that group when that happens, it gets killed before it can actually hand off to the browser. The report file gets written to disk just fine, but nothing actually ever opens. The fix for this, at least on Unix I found, is to spawn xdg open or open directly into a brand new process group with detached standard IO, so it survives the parent group dying. Everywhere else, or if that opener binary is missing, I just fall back to the cross-platform web browser crate. And the whole thing is best effort throughout. Any error gets swallowed because a browser failing to open should never be able to hang or crash somebody's editor on quit. Next is the actual handler implementation, which is the real meat of main RS. This is the RPC dispatch. Handle notify covers the fire and forget side. Setup rebuilds config from whatever args Lua sent over. It also creates a brand new session. That's actually what marks the start of a session, not the plugin loading. Key pulls the token, mode, line, column, and text out of the args and forwards all of it into session record key. There's an early return if the token's empty, which mirrors a guard we'll see on the Lua side later. Cursor just updates last position, which is cheap tracking that keeps the very last run of a session accurate, even though there's no next keystroke to read the ending position from. And buff inserts into a B-tree set of files touch, which shows up in the summary at the bottom of the report. Handle request covers the two calls that actually expect a reply. Report is the interesting one. The reason argument matters here: exit respects min keys, so it'll skip writing a report for a session that was too short to be worth judging, while manual, which comes from Mashless report, always writes a report. Either way, it runs analyzer analyze and then report write, then open in browser, then hands the path back over RPC. Open latest is what powers Mashless. It just finds and opens the newest report without rerunning any analysis. And then deliberately last, even though it's the entry point, is function main itself. It's a Tokyo main async function that calls create new parent handler. Neovim RS attaches to Neovim over standard IO pipes that are already open, because Neovim started this process with job start and RPC equals to true. So those pipes exist before the Rust code even runs. From there, it just awaits the IO loop until Neovim closes the channel, which is just a normal :Q or until something errors, in which case it tries to surface that error back into Neovim. but silently ignores the reader closed or channel closed error, since those just mean the editor exited normally. So that's the whole control flow. Now let's actually follow one keystroke all the way through, starting with what actually holds the session data, recorder RS. Record key is the function main RS calls on every single key notification. And this is where a raw keystroke actually turns into structured state. At the top, there's arrows and is arrow, just the 4 arrow key tokens, and I check for them separately in normal mode versus insert mode, because normal mode arrows and insert mode arrows end up getting different tips later. And then there's keep text, which decides that only L, H, right, left, W, B, E, capital W, capital B, and capital E hang onto the current line's text. The reason is that those are the only motions where the analyzer can later say something like, you landed on this character, if that character would have gotten there directly. There's no reason to pay the cost of shipping line text along with every single keystroke when most of them will never use it. Classify collapses Neovim's raw mode string down to just normal, visual, insert, or other. Key entry is just one recorded keystroke. The token, the cursor position, and that optional text. Config is the 5 tunables, output dir, min keys, vmin, hmin, xmin, with defaults that match the Lua defaults exactly. And session holds the start time, the ordered keylog, total keys, insert arrows, and set of files touched, and the last cursor position. Record key itself is a match. Insert mode arrows just increment a counter and stop there because I don't want insert mode typing polluting the keylog. Normal and visual mode keys get pushed onto the keylog, with text attached only if keep text says it's worth keeping. And everything else, command line mode, terminal mode, whatever, just gets dropped entirely, because that's not what this plugin is trying to coach you on. Next up is Analyzer RS, which is where the keylog actually turns into findings. Analyze gets called exactly once, at report time. It takes the whole keylog and turns it into a structured analysis. The core trick that the whole thing is built on is find runs, which walks the keylog once and groups consecutive identical tokens into a run with the token, the count, and a start in indices. So once you have that, everything else in this file is really just for each run, decide whether it's interesting, and if so, why. The analyze function matches over those runs category by category, and this maps one-to-one onto the tips you'll actually see rendered in the report. So it's a good place to preview what it's going to say. Vertical runs, J, K, and the arrow keys get flagged once they hit vmin, and I compute the actual line distance traveled using the cursor position of the next key, or last position if it's the very last run in the session, which is exactly why the Lua shim tracks cursor moved separately. Wasted keys get estimated as count minus 3, since an optimal count minus j costs about 3 keystrokes. Horizontal runs work the same way against hmin, except I also try to pull out the actual character the run landed on from the last saved line text. That's the payoff for keep text back in recorder RS. And I filter out landing on a space since F space isn't really a useful suggestion to anybody. Then there's X runs, DD runs, where D tokens come in pairs for a literal DD, so I divide the count by 2. Long WBE chains and long U streaks, and they're all the same shape. Check a threshold, push a finding, add to wasted. And right at the bottom, there's the efficiency score, which is just 1 minus wasted over total keys. Clamp between 0 and 100. There's also a config test module down at the bottom with real unit tests directly against analyze, things like X run flagged and mix runs, which is a nice thing to point out since none of this module touches the editor at all, so the core logic is fully testable on its own. Report RS is the last stop on the Rust side. Analysis and session go in, one HTML file comes out. Build tips is where the analysis actually turns into English. And there's also this little rabbit hole of functions, key name, expand key, decipher, inline, that handle Vim notation. Tip text gets written in this markdownish syntax, backticks for code, double asterisks for bold, and the inline function walks through it, turning backtick spans into actual code tags. But inside those spans specifically, it also expands raw key notation. So hitting the carriage return key, which most people just call enter, shows up in the report as the word enter, or holding control and tapping O shows up as control O, so the report reads like actual English instead of raw Vim notation. There are test cases at the bottom of the file that double as documentation for everything that it handles. Font face and style are also embedded at compile time using include string. The font is base64 encoded, so the report that gets generated is one completely self-contained HTML file that needs zero network access to view, even fully offline. The styles actually used to live inline on this file, and I pulled them out into report CSS just for more readability. And the font got added afterwards specifically so the report doesn't silently look wrong if you open it with no internet connection. The render function walks through the summary, and then the tips sorted most severe first, the static motion cheat sheet table, and then a footer, and wraps the whole thing in an HTML shell. Write timestamps the file name as Mashless and then a date and time, then .html, and writes it out under output dir. And latest globs that output directory for anything matching that naming pattern, and returns the newest one by sorting on the timestamp in the file name. And that's what powers both Mashless command and the your report is ready notice that you get on the next startup. Now, everything I talked about so far runs outside of Neovim in a totally separate process. This file, Lua Mashless init Lua, is the only code that actually runs inside the editor, and it's small on purpose. mconfig holds the defaults, the same 5 knobs that Recorder RS's config mirrors. The one that's Lua only is notify on enter, which is, hey, your last session's report is waiting, nudge that you get on startup. Binary path locates target release Mashless or the exe on Windows, relative to this file's own path using debug.getinfo, so the plugin never needs anything on your path. It just needs to have been built once. And that's also exactly why lazy Neovim spec has build equals cargo build release on it, so updating the plugin automatically rebuilds the binary. Then M setup is really the whole shim. It merges whatever options you pass in over the defaults and bails out early if the plugin's disabled. Then it checks that the binary actually exists and is executable. And if it's not, it gives you a clear error pointing at the fix. Go run cargo build release instead of just failing silently. Then comes the line that actually kicks everything off. Vim function job start exe rpc equal true, which spawns the Rust process and opens up that message pack RPC channel that we talked about earlier. So right after that, it ships the config over with Vim RPC notify channel setup, which, like we saw in the main RS, is what also resets the session. Then it seeds the very first file that you opened with a buff notification, because otherwise the file your session actually started on would never show up in the report's file list. Then there's Vim onKey, the actual capture callback. Worth pausing on this one specifically because it's a little different from the other Neovim exposed hooks that we're going to run into in a second, like auto commands. Auto commands only fire on higher level events. A buffer got read, the cursor moved, stuff like that. Vim onKey sits underneath all of that. It's Neovim handling a plugin every single keystroke as it comes in, before Neovim itself has even decided what keystroke is going to do. You register a callback with it, and Neovim calls your function for every key. It fires before the key actually gets processed, so the cursor position I read here is generally where the motion started from. The important guard is typed nil or typed blank, which is how the shim tells apart a key that you actually pressed from a key that Neovim generated internally, like X refeeding itself as DL under the hood. Skipping those is exactly what keeps a real run of 3 X's intact instead of getting shattered by phantom keys. And it's the Lua-side mirror of both the keep text table back in the Recorder RS and the empty token guard in main RS's key handler. Then Vim function keytrans typed turns the raw bytes into that human readable token form. Things like the up arrow key or holding control and tapping O that everything downstream expects. And the whole callback is wrapped in pcall because recording must never be able to break actual editing. After that, there are 3 auto commands. Cursor moved keeps the last position fresh. Buff read post and buff new file track which files you visited, and then the important one, Vim leave pre does a blocking RPC request with report and exit. So the report is fully written to disk before Neovim is allowed to exit. And finally, Mashless and Mashless report are just thin wrappers. One calls open latest, the other fires off an on-demand RPC request with report and manual. So to recap, Lua captures keystrokes because it has to, and Rust does everything else because it doesn't have to be Lua. A keystroke becomes a key entry, runs of keystrokes become findings, findings become plain English, and plain English becomes a self-contained HTML file that pops up in your browser the second you quit. And that's really the whole point. This is the learn passively while I'm actually editing a file version of Vim training that I wanted, and I just couldn't find that anywhere else. And if you want to try it yourself, as always, the repo link is in the description below. Let me know in the comments what other patterns you wanted to flag. And thanks for watching. Bye!